Yo everybody, what's going on? This will be the first lecture video for Unit 7, which is all about air pollution. And this unit is pretty brief compared to the other ones, but we will get into the basics today in terms of what is air pollution and how it impacts our health. And we will also explore throughout the unit more complex questions like how it impacts the environment, how different people in different communities experience air pollution, the inequities and environmental injustices with air pollution, and curious questions like how rush hour impacts our human health as well. So today we're just going to introduce the topics of air pollution. Air pollution is basically any gas or particulate matter that is released in the atmosphere that can either impact the climate or harm living organisms. Okay, so impacting the climate or harming living organisms. There are primary pollutants. These are pollutants that are released directly into the atmosphere from a source such as a smokestack or a car exhaust engine or even a fireplace. And then there are secondary pollutants that form through chemical reactions within the atmosphere. They aren't released from a particular source. They are formed chemically in the atmosphere. When we look at air pollution, keep in mind that it is the air in the atmosphere is a global resource. It is shared. Tragedy of commons applies here when we talk about air pollution because air pollution doesn't stay put, whether it's from farms or industry or transportation, cities, or even natural sources of air pollution. It all ends up in the atmosphere and it's all a shared resource. So it's a very integrated system in terms of where air pollution is formed, but then also where it ends up. It can also travel very far as a result. There are 6 types of air pollutants regulated in the U.S. by the Environmental Protection Agency and the Clean Air Act that we will talk about throughout the unit. And these are also the air pollutants that are used to determine the air quality index, which we will take a look at in class. So the first one is nitrogen oxides, NOx. The second is ozone. We've talked about ozone before in the stratosphere. We're only looking at tropospheric ozone here. This is the only ozone is only considered an air pollutant when it's in the troposphere, which is the lowest level of the atmosphere. Sulfur dioxide, SO2, carbon monoxide, CO, and lead, other toxic metals like mercury as well, and lastly, particulate matter. So I'm going to go through each one of these now. When we look at the air pollutant breakdown, this is from 2014, you can see a lot of it is carbon monoxide and a decent chunk are also nitrogen oxides and something else called volatile organic compounds, which I've mentioned before and I'll talk about towards the end. And when we look at these 6 different air pollutants, they have, or all air pollutants really, but those 6 as well, have different residence times, which is basically an indicator of how long it will stay in the atmosphere, right? Some air pollutants, like sulfur dioxide, will only linger in the atmosphere for a couple hours to days before they break down and they react, whereas air pollutants like methane or carbon dioxide, CFCs, can stay in the atmosphere for years to decades to centuries. So they'll hang around for a really long time. So the residence time can have a big impact on whether it impacts the health or the climate, or both. So let's get into it. So nitrogen oxides we represent with NOx because it can be NO or NO2. And these come primarily from fossil fuel combustion. NOx, like I said, it comes from fossil fuel combustion because nitrogen gas reacts with oxygen at high heat to form NOx. And this is why idling your cars is not a great thing. You might think it's because you're producing CO2 and you're wasting gasoline, and yes, that's true, but the big thing is when you idle your car, your engine stays warm, which facilitates this reaction, right? It catalyzes the reaction between nitrogen and oxygen, forming nitrogen dioxide or nitrogen oxide. It can naturally come from forest fires, lightning, or even soil microbes, but it is a respiratory irritant. It can do damage to the lungs if exposed over time. Edemas, emphysema, asthma, irritation, pulmonary fibrosis, you name it. But it has an extremely low residence time. It can also form nitric acid when in the air and reacting with water to form acid rain. And it is also a contributor to smog, which we'll talk about later in the unit. Second is tropospheric ozone. not stratospheric ozone, but tropospheric ozone. This is a secondary air pollutant, meaning that it is formed in the atmosphere when sunlight or when I should say water and volatile organic compounds react with nitrogen oxide and oxygen in the presence of sunlight. Right, so we've got a couple of different moving pieces here, but they require sunlight or heat to react. Tropospheric ozone is a respiratory irritant. It's damaging to breathe, and it can also damage plant tissues. It's a major component of smog, and it has an intermediate residence time, so it will hang around for a little bit. When we look at ozone formation, oxygen is split by sunlight. The free loose oxygens will bind to another oxygen molecule, which will form a 3-oxygen molecule that is ozone. This is a completely natural process. However, it can be somewhat artificially supplemented, so to speak, because air pollutants that humans release, such as nitrogen oxides and volatile organic compounds, can react in the presence of sunlight and to form ozone at a much higher rate. So this is a human influence process. So ozone can be formed naturally or anthropogenically. So the ozone that's in the stratosphere, we've talked about how it shields the Earth from UV rays, and which reduces the chance of skin cancer. That's in the stratosphere where the ozone layer is. That ozone layer has been broken down by air pollutants such as CFCs, which come from things like aerosols like hairspray, fridges, and fire extinguishers. Luckily, we've actually managed to fix that ozone depletion in the stratosphere. Just a reminder, that has nothing to do with climate change or separate issues. But the tropospheric ozone is an entirely different beast, right? It's the same molecule, but it has different impacts. What we see with tropospheric ozone is that if we increase the amount of nitrous oxides and increase the amount of VOCs, that means more ozone at the ground level. And you can see that it can come and go very quickly. Here's a picture in China of ozone and smog formation one day, and the same area 4 days later. So it can move very quickly, come and go, and it can have significant impacts on the air quality. Again, I'm going to emphasize this because it's pretty important that you know this reaction. Nitrous oxide combined with VOCs in the presence of sunlight will form ozone, right? That is a secondary pollutant. Ozone is a major component of smog, but it is not smog itself. And other consequences, respiratory issues, damage to plants, and ozone is also a greenhouse gas, so it can exacerbate climate change. The third air pollutant is sulfur dioxide. We've talked about this when we mentioned acid rain. Natural sources include things like volcano, but it can also come from the combustion of coal, oil, and diesel fuel. It does not come from the combustion of things like regular gasoline or natural gas. It is a bit of it comes from dirtier fossil fuels, so to speak. It is a respiratory irritant, it is harmful to breathe, and it can lead to the formation of acid rain. It luckily has a very short residence time. Number 4 is carbon monoxide. You've probably heard about this before. You probably have detectors in your home. Carbon monoxide is formed when there is incomplete combustion. So there's not enough oxygen present to form CO2 through a combustion reaction. So instead, carbon monoxide is formed, CO. Right? Carbon monoxide, meaning one oxide, as opposed to carbon dioxide, where there's 2. This is especially dangerous indoors because it is a odorless, noiseless gas. It can't be seen, you can't smell it, you can't hear it, and it is extremely dangerous to breathe. So in enclosed locations, it can do a lot of damage, and it hangs around in the atmosphere for a very long time. The reason that it is dangerous is because the red blood cells in your body have a protein you've probably heard of called hemoglobin, which binds to oxygen, and that allows red blood cells to distribute oxygen throughout your body, which is an important reactant for the combustion reaction, cellular respiration. So that's why we breathe oxygen and how it gets around the body. The problem is that carbon monoxide has a stronger binding affinity to hemoglobin than oxygen does. So if you've got carbon monoxide and oxygen in your blood, the carbon monoxide is going to take up all the slots where oxygen could bind, which means that your body is going to be deprived of oxygen. And this can lead to a variety of different things like headaches, nausea, but also you can sort of becoming very forgetful, you can pass out, and you can eventually die. Again, it's really only a major issue indoors. One of the reasons you don't want to start your car with your garage closed and leave it running, because your car will start to release carbon monoxide in the garage and can build up. So don't do that ever. You could die. Number 5 is lead. Lead and other heavy metals like gasoline, or sorry, not gasoline, like mercury. Lead is often found in gasoline, but it was phased out in the late 90s. Now you usually get unleaded gasoline, but it can still be found in paint in older buildings, in the pipes in places like Flint, Michigan, and also in the paint used in many children's toys. It is toxic to the central nervous system. It can lead to lead poisoning. It can lead to severe drops in IQ and illness and even death. And lastly, particulate matter. These are small particles, things like dust, and they are released from combustion of fossil fuels and biomass, like wood on a campfire, but also they can be released from your car. Diesel is much worse than regular gasoline in terms of particulate matter, but it also can include things like dust, soot, ash, sand that's in the air. It can release from volcanoes. It could be asbestos. Here you can see a picture of dust blowing off the coast of Africa westward towards the United States. That's particulate matter. Pollen is also particulate matter. This can block out, particulate matter in general can block out the sunlight, but it has a very short residence time. It tends to settle into the ground relatively quickly. You can see particulate matter with your eyes, depending on how big it is. There are 3 different sizes. Anything larger than 10 microns is going to be caught in your nose and throat, filtered out by your mucus, thankfully, but things around 10 microns or so will be too small to be filtered out by your respiratory tract. Those are a major health concern. And anything less than 2.5 microns or micrometers is a very large health concern. They can lodge in your lungs, in your alveoli for a long time, tend to be more toxic. These can lead to things like emphysema, asthma, etc. And there's one that is not regulated by the EPA that I've mentioned before that you should be familiar with, and that's volatile organic compounds. These are hydrocarbons, so combinations of carbon and hydrogen, and they can come from building supplies, household products like paint, glue, adhesives, dyes, toilet cleaners, etc. Basically anything that has a smell, a strong chemical smell, is got a volatile organic compound. Gasoline is a volatile organic compound. I'm sure you smell that at the gas station. Plants release VOCs naturally. Pine trees have a very strong scent. That's a VOC. But they can also be released from the extraction and combustion of fossil fuels, like extracting natural gas can also release a lot of VOCs. And these are a precursor to smog, and they are crucial in the formation of ozone as well. Lots of different examples of VOCs. Lacquers, resins, paint, printing ink, plastics, rubbers, dry cleaning solutions, gasoline, tobacco smoke, anything that's got C's and H's in it is most likely a VOC. And the other question you might be wondering is, I haven't mentioned carbon dioxide yet. We talk about that all the time. Isn't that an air pollutant? Well, if you think about the definition of air pollutant, it's something that affects either the climate or the health of living organisms. And by that definition, carbon dioxide is an air pollutant because it impacts the climate through it's a greenhouse gas and it increases climate change. But carbon dioxide is not dangerous to breathe. It does not directly harm living organisms. You're probably breathing it right now. And so it's really important that you understand that distinction. Carbon dioxide is an air pollutant in that it alters the climate, but it is not dangerous to breathe. It is not harmful to human health directly. It can cause climate change, which can harm human health indirectly, but it is not dangerous to breathe. So really make sure you understand that. So what do we do about air pollution? The first thing we can do is enact laws, we can change our behavior, and we can change technology. We'll dig into all of these later on in the unit as well. The Clean Air Act of 1963, definitely need to know about this. It's been amended a number of times to bolster its strength. It sets standards for automobiles and factories. It imposes limits on the amount of emissions, not just of CO2, but of all the other pollutants I just mentioned. It funds a nationwide air quality monitoring system that you can view probably in Apple Maps, Google Maps, or your weather app. You can look at the air quality all around the world. And the Clean Air Act has been majorly successful. You can see, if you look at this graph, a massive reduction in air pollutants for carbon monoxide, nitrous oxide, all of the ones I've talked about, 99% reduction in the amount of lead in the atmosphere thanks to the Clean Air Act. So we've seen some massive declines. They phased out leaded gasoline, which is why we see this major drop. And it's saved over 200,000 lives since its forming. And it also had a big impact on acid rain, which I've mentioned before. Another form of legislation is this idea of cap and trade, where they set a standard for the amount of emissions, and they give each company basically a number of permits saying, hey, you can emit X amount of emissions per year. And if a company does not emit all of the pollutants that it is allowed to emit, right? So it's, say, this diagram, right? They put a cap on the amount of emissions you can release. And if you're releasing less than that, you can actually sell some of your permits to a company that needs them because they're emitting too many pollutants. So what that does is it ensures that the same amount, the amount of pollutants are being regulated in the atmosphere, and companies that produce less air pollutants are benefiting because they don't have to pay for the permits. They can actually sell them to other companies. And companies that emit more than the cap will have to pay for more allowances and be disadvantaged because of that. So it incentivizes people or companies to reduce the amount of air pollutants that they release. And this has had a big impact on air pollutants as well. You can see each bar represents a different time period, and you can see the number of days with unhealthy air by year have decreased substantially in a lot of cities from around the country. So air pollution regulation is having an impact. And we need to make sure that we're not just focused on the U.S., but we're looking at developing countries as well. We know that as countries go through the demographic transition, they become more reliant on fossil fuels. If we can help them skip through that and get into renewable energy quicker, it's going to be better for everybody because, like I said, the atmosphere is connected. Tragedy of the commons. It's our air too. We can't just take care of ourselves and expect everything to be fine. The additional things we can do are make some cultural changes, driving less, walking more, reducing our reliance on fossil fuels, educating one another, right? Behavioral changes. And lastly, technological advancements. Catalytic converters are found in your car, and these reduce the amount of carbon monoxide, nitrous oxide, and VOC emissions from your car, which is great. So carbon monoxide, nitrogen oxide, and hydrocarbons go in, and what comes out is nitrogen, carbon dioxide, and water. Obviously, carbon dioxide is still a problem, but it's better than having all of these air pollutants as well. So you should know the red and the green boxes there. Wet scrubbers, which I will talk about more detail later, but these are devices installed in coal-burning power plants to help trap air pollutants like sulfur dioxide. And basically, they're simulating acid rain in this tank to prevent it from happening in the atmosphere. Baghouse filters, which are literally just like really high-quality filters, can help reduce particulate matter from coal-burning power plants. Electrostatic precipitators use a static charge to remove particulate matter and smoke from the air before it's released into the atmosphere. And fluidized bed combustion. Again, I will talk about all of these in more detail towards the end of the unit, but I just want to introduce them to you now. This one combusts things like coal at a rapid, intense rates by injecting pure oxygen into the bed. And also, that's going to increase the efficiency of combustion and lead to less sulfur dioxide. And they also inject limestone into the tube to help. You can see it here to help reduce the formation of sulfur dioxide, because this can form an acid and lime is basic, so the two will have a neutralizing chemical reaction. Okay, so that's it for an introduction to air pollution. We will dig into all these topics more as the unit goes on. Please bring your questions to class.